Hi, this video is going to be looking at velocity time graphs. First, I'm just going to explain what the difference is between speed and velocity. Speed is how fast you are travelling and it has nothing to do with direction. For example, I could be travelling at a speed of 40 miles an hour. Velocity is the speed of something with respect to a direction. For example, a velocity would be 40 meters per second in a northwards direction. This brings us on to velocity time graphs. Velocity time graphs plot velocity of an object against time. Time is plotted on the x-axis and velocity is plotted on the y-axis. But what does the information on a velocity time graph actually show us? The gradient of a velocity time graph is acceleration. Upward sloping parts of the line are acceleration and downward sloping parts of the line are deceleration. Flat sections of the graph represent an object continuing at the same speed. The object would be stationary if the line was following the x-axis, and this is because when the line is on the x-axis, the velocity will be 0, and a velocity of 0 means that the object is stationary. The greater the gradient, i.e. the steeper the line, the greater the acceleration is. So let's have a look at this velocity time graph in more detail. We can split the velocity time graph into different periods. The first period we're going to take is from 0 to 15 seconds. Between this period, the gradient of the line is constant, and this means that there's a constant rate of acceleration. The object is getting faster and faster. The object is stationary, so it has a velocity of 0, and then after 15 seconds, the object is travelling at 12 meters per second. The next period is between 15 and 25 seconds. Between this period, the line is flat. It has a gradient of 0. This means that the object is travelling at a constant speed, and the speed that it's travelling at is 12 meters per second. The next period is between 25 and 30 seconds. In this period, the gradient of the line is increasing. The line is getting steeper and steeper. This means that the object is accelerating at an increasing rate. So in the first few seconds of this time period, the object speed is increasing, but only by a few meters per second. Towards the end of the time period, the object speed is increasing, but it's increasing at an ever-increasing rate. We then have another period where the object remains at a constant speed. The object's constant speed is 27 meters per second, and it remains at this speed for 5 seconds. The final period is the last 15 seconds, between 35 seconds and 50 seconds. During this time period, the object is decelerating at a constant rate. It is decelerating at a constant rate because the gradient of the line is the same along the whole length of the line between 35 and 50 seconds. We can work out the distance travelled by working out the area under the velocity time line. You are only required to do this if you are sitting the higher tier paper. So let's work out how far this object travelled in its first 25 seconds. The easiest way to work the distance travelled out is to split the graph into two sections. The first section is going to be between 0 and 15 seconds, and this is when the object is accelerating. So we're going to have a triangle here. The second section is between 15 and 25 seconds, and this is when the object has a constant velocity. So it means that the object is travelling at the same speed. So in order to work out the area of the triangle, we do the base times the height and then times this by 0.5. So the base is 15 seconds and the height is 12. So we do a half times 15 times 12. And this gives us a value of 90. We work out the second section by doing base times height. The base for this is 10 seconds, and we get this by doing 25 minus 15. 25 is where the period ends, and 15 is where this period starts. So that gives us 10 seconds, and the height is 12. So we do 10 times 12, and this gives us a value of 120. We then add this to the first section, which was 90, and this gives us a value of 210. So in the first 25 seconds, the object travelled 210 meters. We're now going to look at acceleration. Acceleration is how quickly the velocity of an object is changing. It is measured in meters per second squared. It is worked out by using the following formula. Acceleration equals change in velocity divided by time taken. We work out the change in velocity by doing the final velocity, which we're going to denote as v, minus the initial velocity, which we're going to note as u. So we do v minus u, and that gives us the change in velocity. Let's have an example. Suppose that we have a runner that was travelling at 5 meters per second. He then accelerates to 11 meters per second in 5 seconds. What is his acceleration rate? First, we need to work out our runner's change in velocity. His initial velocity was 5 meters per second, and this is u, and his final velocity is 11 meters per second, and this is v. His change in velocity is therefore 6 meters per second. We do v minus u, which is 11 minus 5, and this gives us 6 meters per second. We then divide the change in velocity by the time that the acceleration took. The acceleration took 5 seconds. Therefore, our runner is accelerating at 6 meters per second divided by 5 seconds, and that gives us 1.2 meters per second squared. We can work out the acceleration from a velocity time graph. We work out the acceleration by dividing the change in the velocity, which is the vertical change, by the amount of time, which is the horizontal change. So let's work out the acceleration of our object in the first 15 seconds. Our object has an initial velocity of 0. The object is initially stationary. It then has a final velocity at 15 seconds of 12 meters per second. So the change in velocity is 12 minus 0, and this is 12 meters per second. The time period is 15 seconds. So we do 12 divided by 15, and this gives us a value of 0.8 meters per second squared. This brings us to the end of this video. There is more content, quizzes and past papers on the website. The website is www.elevise.co.uk.